more and more compared to the previous elections. What I see is the blues are where females out voted more. So 84.48 here means of all the registered male voters, 84% voted in that election or in that series of elections. Of all the registered male voters, 84% of them voted. But 86 voted. So Puducherry from 2006 itself, the blues are the ones where women's number is more. 86.29 is more than 84.48. 86.97, 83.97. So women were always voting more. Where has the trend, you are talking about trend has changed. Women have always been voting more. Here, Kerala, women have been voting less than the males. But the trend is not changing. In fact, 74.78 has dropped to 73.84. What is about increase? There is nothing increase. Okay, the difference has come down actually. Okay, and then this is all the same. Mizoram, something has happened. Less women have voted. I don't know, in none of the states, the story is not there that more and more women are voting. When they are voting, they have been voting for the past 10 years anyway. What are we talking about the trend? The whole analysis is messed up there. There is no story. Essentially, there is no story. They have built a story of this. And then the final one, data presentation. Pie charts, by definition, you should be getting. The worst form of a chart, unless you have only 2 or 3 groups that you want to show as part of a whole, pie chart should be avoided. But that is not my message. That message I will pass on in my data visualization class. Here, the first thing I see when I see numbers in newspapers, I start doing my additions and subtractions only. Now here is Maharashtra elections after the general elections last 2 years back. Total MLAs 288. These are the male MLAs and these are the female MLAs. So this thing is the female, this is the male. Now I see, okay, BJP 110 out of the total 122 are male. 12 out of 122 are female. So 110 and 112, 122 adds up. Shiv Sena 61 out of 63 are male. No female. Where are those two? What happened to them? And this is small data set. See, 10 or 15 data points. You don't need more than this for this plot. NDTV, probably the best channel for news analysis, for election analysis. I mean, they are the ones who revolutionized election analysis. We used to look out for them and there was only Doordarshan back in those days and no 24-hour channel. This was great when Pritesh Nandi or Pranay Roy will come and otherwise. Nobody will do better. And this is the state it has come down to. NCP 37 out of 41. Four NCP members also gone. Congress 35 out of 42. There are 6 women also. 1 person Congress gone. Others are 10 out of 13 and 3 out of 30. So others are fine. So if you just really add up the denominator will add up to 288. The numerator doesn't add up. How can you make such a mistake in that presentation? Simple thing. Of course, the pie chart itself is the wrong presentation. What is a better presentation is that. Okay, for this pie might work. 257 and 31 female, 257 male. 288 is okay. This is a better representation, but there are problems here as well. BJP, it says 122, which means the total is 122. How do I know how many are there and how many are here? That's a huge data presentation issue as well. Now if I go by that thing, I have 61 Shiv Sena. If 122 is the total, then 61 should be total, even if I am unable to see the small number. If 61 is total, then this should be 61 out of 61. So there is a tax issue. If that is the case, then the denominator will not add up to 288, but this adds up to 288. Fundamentally, it is. So, and the other problem is, for making two types of charts, they must have created two different tables. Why can't you make? Because this information and this information are contradictory. Why do you need for such a small data set to create two different tables for two different charts? From one table, create two different charts. But fundamentally, everything wrong. Okay? So this is where many problems appear. Data collection, data gathering, data understanding, data analysis, after you analyze it, and data presentation. 4 areas where you have problems with respect to statistics. Haryana also had a similar problem. Adding up doesn't work in some cases. Okay. So that is election analysis where you see statistics done right or wrong, but statistics. Then the economy, 9% growth to cut poverty by 56%. The headlines will be screaming. Technically they will be right. The message they will pass on will be wrong. Okay. What they talk about is, if India is able to see a growth of 9%, then the number of people below poverty will be reduced to 17.7 crores in 2019 against 26.9 in 2012. So that's a 9 crore reduction. 9 crore out of 27 is, nearly, it's not 36, 33, but 36 sounds like a good thing. When you talk in percentages, you also should give the baseline. 1 crore out of 2 crores is 50%. Now, handling 1 crore might be easier than handling this other thing. So, the baseline, percentages when you talk about, it's always good to give the numbers also. They have done. It's just that the headlines will scream something different and give you a different message. But in the same article, what they are saying, if India grew at 9%, anyway not possible, grew at 6.5%, then the number of poor will come down from 26.9 to 22.2. Or if the growth was 5%, it will come down only from 26.9 to 25.6%. Okay? So some numbers are being given, 6.5% growth, 5%, 9%, whatever. And then we have seen this headlines for the past 1 year or so. We have been seeing this repeatedly. Personally, I don't know what is changing here, but India beats China, grows 7.5% in Q4. Okay, and the fastest growing economy in the world. And then Dr. Rajan, RBI governor, says, I don't know what is happening, because he says, Dr. Rajan said there is a contradiction between the high GDP numbers and the poor corporate earnings, along with lack of any visible pickup in demand. And all prices increasing, everything, so we don't know. But, and that was 2014-15 time frame. 2016, June 2nd, we are still, the growth of 7.6% for the year is mixed with news that is cause for concern. The decrease in investment growth at 3.9% for this year compared to 4.9% the previous year. In all of this, what had happened last year in January was some of our statisticians felt that, see those growth numbers, poverty has to be reduced. So 6.5%, 5%, 9%. So our central statistical organization came up with a brilliant idea to reduce poverty. It created a new formula to calculate, which by default added approximately 2.2% to the GDP number. So in 2013-14, when we were saying that India grew miserably at 4.7%, suddenly that number became 6.9%, one of the best in the world. About 2.2% got added. Not saying that it is wrong to do what was done. It is good. The new methodology is more in tune with the global methods. So it should be done. But now when you say 7.5%, it is equal to something like 5.3, 5.4% in the past. So till the time the new methodology can be used as a comparative thing for the economy, till that time you have to show both versions. You have to say, based on the past calculations, this is this much. Based on new calculations, this is this much. And after a year or 2 years, now you can forget about the past one. This is more in tune with the global world now. So people just use these numbers to mislead like anything. Fundamentally on the ground, nothing has changed. But now we are the fastest growing thing in the world. So that's where you have to be cautious. As data scientists, you should not get carried away by various biases this way or that way or whatever. You should look at numbers. You should listen to numbers. Some domains we may not understand, which is fine. But you always, as data scientists, focus on numbers. Don't go by anything else. Okay. So this is what is happening. That was economy. Previously elections. I'm showing statistics all around you. Cholesterol is not a threat. US to remove high cholesterol food from not a list. Okay? Since 1970s or 80s, people have been telling you high fat thing, etc. will kill you. Now suddenly they said there is no proof. So you had stopped eating all that. You were not having fun. All that butter and nuts and full fat dairy products. I have been doing all that, but then I don't eat eggs or meat or anything. But if you were missing out on all those things, eat people, just eat everything. Okay, whatever you eat. Okay, because cholesterol is not a threat anymore. Now, statistically, of course, I cannot guarantee. 10 years later, now that you start eating all this, 10 years later, I will come back and say, well, the evidence shows that you are already dead. So. But that's statistics, and we will learn how that inferences are made and how confidences and hypothesis testing and all those things come into play into these kinds of things. What evidence means, but that's what it is. The 70s, 80s, and 90s were non-fat years. Now they say there is no link between cholesterol and heart attack. Okay. Well, what does this say? I have not seen this thing. When we eat more foods rich in this compound, our bodies make less. If we deprive ourselves of foods such as high in cholesterol, such as eggs and butter, our body revs up its cholesterol synthesis. Okay, so actually it was there saying, if you don't eat it, it will be harmful for you. So please eat. Okay. Continuing on with the medical thing, and this I will advise all of you to get tested if you have not. Vitamin D levels, I can guarantee that all 60 people here, they are deficient. Unless you have been taking already the medication. And you won't know anything about it right now. Okay? So, what vitamin D levels are defined as less than 10 nanograms per milliliter. Mayo Clinic says that, and that's an authority in the medical field. Severe deficiency, 10 to 24 mild to moderate, 25 to 80 optimal, more than 80 is dangerous. So you should not keep on taking vitamin D yourself also, because you might get into the toxicity range as well. This is Mayo Clinic. But then vitamin D Council says if you are between 20 and 30, now this guy doesn't have a 20 to 30, he has 10 to 24 and then 25 to 80. But here is 20 to 30, somewhere in between these. Vitamin D Council, not Mayo Clinic, Vitamin D Council says you are deficient. Endocrine Society says you are insufficient somewhere. Institute of Medicine says you are fine, optimal. So, now what do you trust? And to top this all, I somehow found articles from Times of India May 5th and 2 years apart. What it says is, while globally there is a consensus that vitamin levels less than 20 are insufficient. Deficient is less than 20, insufficient between 20 and 30. What global consensus? We just saw 4 different organizations talking different numbers. That's okay, we can live with that. But then there was a study somewhere in Denmark. Now the units have changed, but these units correspond to 20 and 40. So if it is less than 20 or more than 40, then there is a greater connection to death. Now this guy says greater than 40, there is a connection to death. That guy says up to 80, you would have been fine, more than 80. What do I do now? So numbers are there all around you, and it's a complex subject. I'm not saying anybody is trying to mislead, but people do also. And one of the doctors, the nature cure doctor that I visited once, he was telling me about I think diabetes. He said that when he was younger, the number being given was up to 120 or something was fine, and now it is 100 only. I think they are saying something like that.
140 is considered to be the mid range.
Now?
So what it is from 120, as you said, they said earlier 120 was the mid range, and then they said no, 120 is not.
Now you have to take medication if you are less than 120 or what?
No, if you are less than 140.
Well, less than 140. Okay. And previously it was something else. Well, what you were saying, it's a multi-billion-dollar industry where they just changed the cutoff to be able to make you take medicine earlier for even other values. So it might be intentional, it might be because of the differences in methods of calculating these things. Variety of complexities are there. But still, how do we know now what to do? Okay? Numbers are greater than 40 says there is a connection to death. That's dangerous because when I tested myself 2 years back, I had dropped down to about 11. I just started doing my annual blood checkup at least. And 11 is not good. So got it tested, and so 3-4 injections, and then monthly some powder and whatever. And then it must have gone up because last year when I checked it was at 32. So must be dropping. By now it must have dropped below 30. We don't get enough good sunlight. So all of us are deficient. When I mentioned this last batch, one of the ladies who had traveled from Pune to take this program, she got tested and she said, yes, you are right, I am deficient. And Deepika was in danger zone. She was at 3. Okay, so please get tested. So yes, because the thing is, if you don't have enough vitamin D, the body will not absorb the calcium. So your bones, etc., will start getting very weak. And they will affect later on in life. Now we can continue, no problem. But it's very essential to maintain your vitamin D. And now there is no other way but to have an annual checkup and mix that powder in the milk or the tablets or injections, depending on whatever the deficiency is. Few months, once a month, once a week, something is given. Then stop, and then next time when you check, if it is fine, maybe next year you don't have to, but then you have to take it again. Vitamin D supplements will have to be taken. Okay? There is no other way you will get enough vitamin D. Please, I care for your health. CPR. No? So we have multiple things going on in some people. So we do that. This is my own blood test. See, when I was dropped in that Krishna river, no, that the photos you saw in that parachute and all that thing. So I had some water in Vijayawada at the time, just normal water. I think it affected my liver, so it went up to 95. I didn't find any reason why it did because I don't drink alcohol also. But it went up to 95, and it said 16 to 63 was the normal range. And last year when I got tested, it came down to 39, so that must have been because of that water, something messed up my body there at that time. But what is more important is it said 16 to 63, same thyroid care agency that I went through, 13 to 40. And see, there they said, okay, anyway he is high, so it doesn't matter, 16 to 63. Here, and let me scare him. 13 to 40, you are at the borderline there. I would have been fine with that thing. But again, it depends on the technology that you have used to calculate those things. So it's not that they are cheating or anything.
numbers make sense, and sometimes they don't make sense. So that is the medical field, medical economics, elections. Here is monsoon weather forecasting, and the minister says that I have to say with a heavy heart that this is last year. This year we had too much of rain here. Okay, 88% of the rainfall of the long period average. That's the forecast from the official department of IMD, the Indian Meteorological Department. Same time, with the same data, SkyMet is India's largest private agency that does that, and they said the forecast was 102% of the long-term average last year's monsoon. So they said the monsoon will be much better. Of course, this was right. The IMD's forecast turned out to be correct. But what they are saying is the past 6 years or so, past 3 years, every single of their projections have been correct. So statistics is being used to predict things like that here as well. Of course, not to say that they are lying or they are not, but it's very complex. The science is complex. Weather forecasting is not an easy thing. So we will see some of that when we talk about confidence intervals and other things, referring to these kinds of activities. Okay. So weather forecasting needs that. So statistics don't lie, but statisticians may. Okay. So numbers are there. So let's. So with that motivation, I hope there is enough motivation that in all fields, medical, economics, healthcare, elections, social stuff, then weather forecasting, everywhere. We see this all around us, all the sports, IPL, anything. Everywhere we see statistics. So let's learn statistics. The problems, as I said, will be in those 4 areas. So let's start understanding basic statistics, but before that, basic statistical terminology. The first thing that you will encounter is something called population and sample. These will be the words that will be thrown at you all the time. Nothing more to talk about it. Population is population, sample is sample. The important thing is that sample should be representative of the population. When you take a sample, if that sample doesn't represent the population, then things like this will happen. Now this is Kentucky, University of Kentucky's baseball team. Two members from the basketball team, two members from the basketball team, and then there are the cheerleaders. Okay? And these are the heights of the cheerleaders, and these are the heights of the basketball players. So now, if I were to do some study and I say, I want to understand the average height of the ladies in University of Kentucky. My population there is all the ladies in University of Kentucky. Population is not the entire world's population. Population is defined based on the problem statement. And the problem statement, what is the average height of all the ladies in University of Kentucky? So, if I say, and this is called convenience sampling, if I say, oh, why should I work hard and take a sample? Let me go to a basketball game and get the heights of all the basketball players. Oh, and the average height is, then I'll say 6 feet 4 inches or something. Alternatively, I just say, okay, let me just get the heights of the cheerleaders, and then I'll say, well, about 4 feet 10 inches or 4 feet 12 inches or 5 feet or something like that. I will come to a wrong conclusion. I have to have some cheerleaders, some basketball players, some people from different races, because racial effect we see. Okay, some Asians, some African Americans, some Caucasian whites, some Chinese, Indians, whatever. Take a representative sample and then say, that's how it should be done. Sample is the representative. Otherwise, we will make mistakes. So population and sample. Then we hear about census and survey. In relationship to this population and sample, census is with respect to population. When I get data from everyone,
projections are a census. When we go to, so you don't go to some localities and say, okay, let me take your votes, and based on that, this is what it is. We don't do that. So that is a census. Or 10-year census anyway happens. Household survey. Survey is same thing from a sample. Exit polls. Just some people I collect and say, who did you vote for or whatever. That's a survey. Or we conduct a lot of surveys. That's for a sample. Population sample. Census and survey is related to population and sample. This is important. Many statisticians also don't know about it. Parameter and statistic. We will use these words. When I use parameter, I am calculating something for a population. So mean, median, mode, whatever, averages I am calculating. When I am saying I have calculated a mean of the population, that is called parameter. The same mean for a sample will be called a statistic. Same thing, calculation is the same, everything is the same. What I am calculating is the same. The use of the word parameter versus statistic is based on whether I am referring to a population or referring to a sample. That's it. Simple things. Then you also see symbols differently. Sometimes you see a mu when you talk about mean, or sometimes you see an X bar. Now that also is related. All the Greek symbols are related to the population, which is a parameter. So when I say mu, it is a parameter, it is the mean of a population. When I say X bar, it is a statistic, it is the mean of a sample. Sigma is the standard deviation, we will talk about that, of a population. Standard deviation of a sample is given with the Roman numeral. So the way to remember, all the Greeks are the population, all the Roman alphabet, or the Latin, or sometimes it's called Roman alphabet, sometimes Latin alphabet. It's the Greek, the Romans, the sample. So Greeks are the population, the Romans are the sample. Then, descriptive and inferential statistics. It's important. All of it is important. Descriptive statistics. When I take a data from a group, it can be a population, it can be a sample. Now it is not related to population versus sample. I take a group and I am describing the data. I am saying the mean of this data is 56.5. The standard deviation of this data is 2.73. I am describing the data. That is descriptive statistics. Inferential or inductive statistics is when I take a sample, I calculate a mean, and then I say, okay, the mean of the sample is this much. So the mean of the population will be this, whatever. I am inferring about a population, about a different group, based on the data collected for some group. That is inferential statistics. So nothing fancy. Don't get. I do. You can go back and now say, oh, I'm now learning about inferential statistics. Everyone else will say, oh, yes. This guy is doing some high five. But all I'm doing is I'm doing the same thing. I'm calculating for a sample. I'm inferring about the population from this thing. What will happen to the larger population? Based on exit polls, I've collected something. I'm saying these many seats will be won for the larger population. So, yes. When you have population, you can, and whenever you have information about population, you use that. You don't infer anything. When you know exactly what it is, there is no inference. So, inferential statistics will not be for population. Population, if you have the data, you describe the population. But when you have a sample and you want to talk about something you don't have, or you cannot process something that you have a whole huge thing and you take a small sample from there, you take it, you analyze it, you from that description, you make an inference about the larger group. That's inferential statistics. Diabetes is a huge problem in India. They'll say, by 2030, 101.2 million people will be having diabetes. Today, 61.3 in the age group of 20 to 79 years have it. So they are, and that too, they are not collected for all the diabetes patients in India. They have taken from some people, some clinics and some doctors, whatever, and then they say 61.3 are there. Even that itself is inferential. And then extrapolating that inference already to 2030. That's a prediction also beyond that. Okay? So that's what descriptive versus inferential. Describing, am I describing or am I inferring about something?
How can we ensure that the sample that we have collected is exactly representing the actual population? Because the figures may go wrong, and that may provide wrong output.
Yes, so your assumption will be that the sample is representative of population, for which, based on the properties of the population, you have to do your due diligence to correct the sample correctly. So if I am, let's say, the exit polls only, let's say, I want to understand the voting behavior of people in, let's say, some areas, Jubilee Hills, Madhapur and Gachibowli areas. Okay. Now, if I say, okay, Jubilee Hills, Madhapur, Gachibowli areas, there is mostly an IT crowd. Let me just go to some IT companies and collect the data from there. That will not be right. Because there are a lot of other people also living. So you have to understand what is the, how is the population distributed in these areas. How many poor people are there? How many middle class are there? How many rich people are there? How many IT people are there? How many non-IT people are there? Different types. Let me collect randomly now from each group based on the percentages. Now, if 70% population is IT crowd, then 70% I should be taking from IT. Within the IT people, I have to see how many men are there, how many women are there. I have to understand the properties of the population and then ensure that the sample is representative and correctly mounted. That's a science by itself, or understanding the domain of it more. Yeah, population with respect to the statement and the problem statement. Okay. So if I want to understand the mileage of cars in Hyderabad, I cannot just go to Jubilee Hills area and get information from all the BMWs and Mercedes and all whatever high-end cars are there. I will have to then try to understand. So my population will then be all the cars in Hyderabad only. If the problem statement had been, I want to understand the mileage of the cars in Jubilee Hills area, my population will be all the cars in Jubilee Hills area. If my problem is, what is the mileage of Honda cars in India? Then I have to go to all kinds of cities and only Honda cars are my population. So population is not all the cars now. Population is based on the business problem. What is it? There, it takes that. Okay. So that is descriptive and inferential. Now, variables and data. This we will hear often. And most of the time, your structured data will come in this format. Okay? Where the top row is going to be the variable, the rest of the thing is data. Variable means something that can take multiple values. For example, duration. Duration of the call. This is universal bank data that you might see there. Some bank is calling new product that the bank has. So duration of the call, 261 minutes, 151 minutes or seconds, whatever that is, 76 seconds, 92 seconds, 198 seconds. The variable is duration, the data is all that. Variable month, because month can take the values of January, February, March, April, 12 different values it can take. So month is a variable, January, February, March, April are all the data. Okay, so that's as simple as that. Okay. And this is the final value, no yes, whatever. Okay. Then variables can be of two different types, dependent and independent. Dependent variable, in simple terms, if you want to think of it, it's on the y-axis, x-axis is the independent variable. Dependent variable is also called the target variable, also called the class variable. In the previous data set, these are all the variables. What is the bank trying to find out? Bank is trying to find out whether they will take the loan or not. They will take the loan or not. So that becomes your dependent variable. This is what I am trying to predict. This is what I am trying to classify, whatever. So this becomes my dependent variable. How am I deciding whether someone will take the loan or not? Based on what is their age, what type of job they have, are they married or not, what type of education, whether they have defaulted in the past or not, how much balance is their savings account, how much money, do they have a housing loan or not, all kinds of variables. I use all of them to predict whether they will take the loan or not. So whether they will take the loan or not is dependent on all these other variables which are independent. Okay. So these are, that is independent. So for any business problem, there will be one dependent variable only. Only one thing you are trying to find out. If you want to find out two different things, you have two different data science problems that you are solving. In each problem, you will solve only one. So, one dependent variable, all the others are independent variables. For example, now tell me here, this is what they have plotted. Is weight dependent on height or height dependent on weight of people? Weight is dependent on height. Anybody for height dependent on weight? So you want to grow taller, then keep on eating. Well, that might anyway grow the height, but yeah, based on height, weight is dependent. Okay. So weight will be then the y-axis, height is the x-axis. Data. So variables can be two. Variables are broken into two things: independent and dependent. Data can be of two types: numeric and categorical. This is important. I keep saying that for every slide. This is important. Now tell me something. If this is 18 kgs of gold, this is 27 kgs of gold, can you make some statements about those two groups of gold? Number of biscuits? Well, is that right? I can build one huge block of gold with. So in the image you might be seeing that, but I am telling you it is 18 kgs there and 27 kgs there. Similar to that, you do an answer, yes?
Numeric variable, number of people, the number of gold bars. Categorical variable, it's a gold bar, it's people.
I think you've gone past me basically. My only question was, there is 18 kgs of gold here, 27 kgs of gold here. Can you talk about these two gold?
This is heavier.
One is more? One is more than the other. Anything else? Similar statement? Volume. 18 kgs, 27 kgs. How do I get the volume?
Same density.
Anything like that. And one thing, I asked very, very simple questions only. Huh? So what you might be thinking as a stupid answer is actually the answer I'm looking for.
For the same number of bricks, the 27 kg will be heavier? I don't know.
Yeah, no, I couldn't find But all I am saying is this is 18 kgs, this is 27 kgs.
The carrot.
But you said yes.
Carrot value may change.
Carrot value.
I'm sorry?
Carrot value may change.
Carrot value. No, I asked much simpler questions than that. I'm not asking for anything that is not there, sir.
The price is different for both of them.
Huh?
Price is different.
Price? I'm not asking for anything that is not here. 18 kgs and 27 kgs.
More or less.
I think this is 9 kgs more than this. That's all I'm asking for. Or 1.5 times, the weight is 1.5 times more than that. What I'm trying to say is, this is numerical variable where I can do some calculations, mathematical calculations. Now, Virat Kohli is 18, Ajinkya Rahane is 27. Can I say Ajinkya Rahane will score 9 times more runs or 9 runs more, or he weighs 9 kgs more than him, or anything? Can I do anything?
No.
I can't do anything. It's the same number. Here I have 18 and here I have 27. Here I have 18, here I have 27. But here the 18 and 27, numeric is not number. First thing you should know. Numeric, what is the number really telling me? Here the number is just categorizing them. It's ID, identification. One has been given number of 18, one has given number of 27. Your employee IDs are there. 1527, 1345. That number, I cannot say that 1347 guy is 200 numbers smarter than the other guy. Nothing like that. There is nothing. It's just an ID. First come, first ID. That's even different. So in numeric variables, you will be able to do some kind of calculations. The numbers mean something and you can talk about them. In categorical variables, they are just categories. Okay? They are just identification. So let's see what type of variables, what type of data is numeric and what type of data is categorical. First, categorical. Categorical can be broken into 2 more groups. Numeric also is broken into 2 groups, but from the practical standpoint, it doesn't matter to us. That's theoretical stuff. Ratio and interval, we don't care. Okay, so we will keep numeric as numeric, but categorical has 2 variations. They have some importance. One is called nominal, the other is called ordinal. Nominal, employee ID or the jersey numbers of the cricketers, or gender, male, female. There is nothing else. You can't talk about anything else. There is no mathematical thing, there is no hierarchy, male, female equal. Religion, any number of religions. There is no hierarchy. They are just categories. 4, 5, 10, 15 different categories. Ethnicity, pin codes, Aadhaar numbers, city, which place were you born in. They are just giving a different category. So these are called nominal, where there is no difference between anything. They are all the same. It's just different categories. Ordinal, on the other hand, there is an order. That's why it is ordinal. Order is there. For example, movie ratings. You see some movies rated 1 star, 2 star, 4 star, 5 star, whatever. There is an order. You know the 5-star movie is much better than the 4-star. 4-star is better than 3-star. In such kinds of ordinal data, although it doesn't make sense in categorical data, calculations don't make sense. But sometimes you see a 3.5 star. Average is calculated. Average rating. How can I do that? Because after all the stars are representing, 5-star means excellent movie. 4-star is very good. 3 is okay. 2 is bad. 1 is worthless. If that is the thing, then what is 3.5? Okay and a half?